My YouTube viewer, this particular video is going to be on the binomial distribution. And so the binomial distribution, it describes the distribution of the number of successes in a fixed number of independent Bernoulli trials with the same probability of success. And so basically in a binomial distribution, you have only two outcomes, either yes or no, success or failure, true or false, on or off. So in order to create this binomial distribution, what we have to do is we have to write it in Python, because that's the language I decided to use. And then what we're going to do is we're going to import 3 libraries that we need to use to actually execute the program. So we're going to import NumPy as NP, which is the numeric library. And then we're going to import matplotlib.pyplot as PLT, which is the visualization library. And finally, we're going to import scipy.stats as stats. Now, stats is the statistical module within the stats library. So after we have imported our libraries, then what we're going to do is we're going to set up the parameters for the binomial distribution. So n equals 25, so you're going to have 25 trials. P equals 0.75, so that's the probability of success in each trial. And the number of samples is 10,000. So we're going to generate the binomial distribution now. Binomial data equals np.random.binomial brackets n, comma, p, comma, number of samples. So you have 25 trials at 75% probability and 10,000 trials. So now we're going to create a histogram of the binomial distribution. So you've got plt.hist brackets binomial data, comma, bins equals np.arrange, bracket 0, comma, n plus 2, brackets minus 0.5, comma, density equals true, comma, color equals sky blue, comma, edge color equals black, comma, alpha equals 0.7. And now we're going to generate the theoretical binomial distribution PMF, that's probability mass function. S equals np.arrange, black brackets 0, comma, n plus 1. PMF, that's probability mass function, equals stats.binom.pmf, brackets x, comma, n, comma, p. And now we're going to plot the PMF on a graph. So plt.plot brackets x, comma, PMF, comma, r dash, comma, LW equals 2, comma, label equals binomial PMF n, comma, p. Now we're going to add our titles and our labels. So you've got your title is binomial distribution, X label is number of successes, Y label is probability, legend, and then we're going to show it. Okay, so it's a little bit difficult. This is your binomial distribution, and you can see that it's skewed to the left. You can see the binomial distribution is skewed to the left. So you have 25 trials at a probability of 75%. So there you go. So where's our, so that's it, probability 75% at 25 trials. So that's it for the binomial distribution. In the next video I make, I'm going to be talking about the Poisson distribution. So I look forward to communicating with you then.